So, this is the second year I've been presenting on blockchains and such stuff. I mean, the last time was actually not last year, but the year before. And believe it or not, I presented about Dogecoin. So, does anybody here know what Doge or Dog or Doggy coin is? Dogecoin, yeah, okay. So, I'll touch a bit on this topic later. Okay, blockchains have been a hype for some time now. I mean, at least in the last 6 months, but even before that. And a common problem I encounter with speaking with people is nobody's really sure outside of really small technical teams what blockchains are. Okay, so just to get an idea, could you raise your hand if you think you know, or if you know what blockchains actually are? So how is this audience on this topic? So raise your hand if you know what blockchain technically really is. Okay, so at most 10% of people, and this is a pretty technical audience. And at 10% of a really technical audience, speaking about the technology which has been hyped for, everywhere, and every single technical magazine or a blog or forum or whatever is a pretty small number. Okay. So, blockchain is the database where Bitcoin stores its coins. I usually use this metaphor. So, a blockchain is a type of database. Okay. So the name blockchain is on the similar level as the name, for example, an SQL database, right? A Bitcoin is an implementation of a blockchain. And a similar implementation may be MySQL or Oracle or PostgreSQL or whatever. So, blockchain is a type of database. Bitcoin is an implementation of a blockchain, right? Make sense? Okay. The major property of blockchains is that data is grouped into blocks. In case of Bitcoins, the blocks are transactions. And the blocks are structured in this way that every new block basically signs cryptographically the block before it. And the block before it signs the one before it. And the block before it, and such stuff. And back to the beginning of time, literally the Genesis. So the idea is that if you have such a structure, its main property is that, cryptographically speaking, is that if somebody changes a block in history, 5 years ago, or 10 years ago, or whatever, this change is automatically detected and rejected by the network. So we have this really, really neat property that data is practically immutable throughout the history. Okay. The process of creating new blocks, and this will be important later, is called mining. Okay, so all those talks about mining blocks, about Bitcoin miners, about Ethereum mining blocks, and everything else is about the creation of new blocks. Now, what this block contains is a completely different matter, and this is another important topic. If you talk about blockchains in cryptocurrency, the blockchain is the database where the transactions are stored, but it can store something else. We'll see later. Cryptocurrency is about the transactions which are stored in this database. So on one level, we have some rules, some algorithms, how blocks are created and how blocks are chained. On another level, we have rules which transactions are valid. Okay, so transactions or cryptocurrencies are an overlay over the blockchain structure. Okay? So we established some rules. We established how data is stored into blocks. We established that these blocks are chained. Okay. And then on top of these rules, we establish the rules which transactions are valid. And this forms a cryptocurrency. On another level, the next level, we can establish that these transactions carry some pieces of code, like computer code, like program languages, like such stuff. And these are overlaid on top of the transactional rules. So this is a layer above it, the next layer. And then we can say that we have, for example, token coins, which are not cryptocurrencies in themselves, but which rely on, for example, Ethereum. And these are again above it, so a layer above it. So tokens are layered on top of smart contracts. Smart contracts are layered on top of transactions, and transactions are layered on top of blockchains. And each of these layers, you can think of it like network layers. If somebody here is a network person and knows about, I don't know, OSI layers and such stuff, each of these layers have its own rules, which constitute what goes into it and how the data is processed on this layer. Today's topic is the blockchain. Okay, so I mentioned Bitcoin, I mentioned Ethereum, I mentioned Dogecoin, and there's probably right now thousands of altcoins, or politically correctly called shitcoins, because once Bitcoin is open sourced, then everybody wants to fork Bitcoin because Bitcoin is successful. So everybody wants to get rich and whatever, and forks its own. I think that at least 95% of altcoins, alternative coins, are made by forking Bitcoin code and just changing a few constants, a few algorithms and such stuff. And, this points to something else. This points that the hype is working. I mean, it's obvious. The hype is working. There's so much hype about cryptocurrencies. There's so much hype about Bitcoin, blockchain, that, people really are constantly trying to find new ways to use them. And, in most cases, this use thing means, to get rich from it. But, there's another thing. And we cannot really talk about Bitcoin, especially Bitcoin, without addressing the problems in how blocks are mined by using the proof of work algorithm or proof of work semantics. Did you know that every single transaction you create and put out into the Bitcoin network basically uses as much energy, electrical energy, as 1.6 American homes in a single day? So each time you create a new transaction in Bitcoin, you are basically spending, enough energy to power 1.6 American homes. And American homes are bigger than creation, right? So there's this problem. I participated in a Facebook argument a few weeks ago, where a person said, okay, so yeah, we are spending enormous amounts of energy to secure the network. We are spending enormous amount of energy for this proof of work algorithms. And because we are spending them, it means that, the algorithms do some useful work for us. And this work is visible in, having a really secure blockchain. But unfortunately, all the major cryptocurrencies together have as much transactional bandwidth in the terms of transactions per second as Croatia. So we are spending an enormous amount of energy, an enormous amount of money which is related to this energy, simply to create a digital economy which is nothing, which has less transactions per second than Croatia. Right? It's a bit insane. Okay, so we'll leave the solution of that particular problem to future generations and hope that they will be merciful for us and such stuff. So, back to basics. What are blockchains good for? And depending on who you ask, you get various answers like everything, like curing the world hunger, bringing peace to Middle East, promoting love among peoples and such stuff. And if you look at a typical article about blockchains in a typical mainstream magazine, you will see that the blockchain is like heavenly gift to people or something. But the blockchain is basically a database. It's a very, very specific database. It's append only. The structure of common blockchains, it doesn't have to be this way, but most common ones are done this way. The structure of blockchain is such that it is an append-only database. New data is appended at the end in new blocks, right? The new blocks also sign all the other blocks and such. In such way, we have the chain, the concept of a chain, but it really is an append-only database. It is a database which is intended to be distributed, across the internet, so across the globe, across the planet. You can have, by using this type of database, this blockchain, you can have a data distribution mechanism which basically spans the entire globe. If you insert the data into a blockchain, if you create a new transaction, this transaction will, all things being ideal, travel the world for Bitcoin in approximately 10 minutes. So your transaction will be visible across the world in 10 minutes. It's a useful property. It also limits the useful speed of such transactions. Blockchains, as currently implemented, are mostly created to be read mostly, write very, very occasionally. This is a great data distribution mechanism, but the need to have a single ledger in case of Bitcoin, in case of all mainstream cryptocurrencies, means that all those data flows into a single blockchain. It is serialized. There is no parallel computation on this level, on the level of blockchain. Everything goes sequentially in it. But on the other point of view, blockchain is what it is, or at least Bitcoin blockchain and similar cryptocurrency blockchains is what it is because it is intended to be a medium of communication, in this case about financial data, between parties which do not trust each other. It is created with cryptographic algorithms precisely in this way and precisely because it enables parties which basically have no reason to trust each other, that suspect each other of cheating, lying, trying to manipulate data, right? And it enables those parties to have an agreement. To have an agreement about how data will be structured. To have an agreement on how they will communicate among themselves on more or less standard or more or less settled grounds. And this is the importance of blockchain as it is. And this is how blockchain could be used outside cryptocurrencies. So all cryptocurrencies today are public blockchains. Everyone can download an application, a Bitcoin wallet, an Ethereum wallet, whatever. Everyone can run those wallets. Everyone can download the entire blockchain. Everyone can create new transactions. And even everyone can mine. And when I say everyone, this is almost statistically true, because statistically speaking, everyone on the earth lives in China. No takers? Okay. Major Bitcoin mining operations are in China. Okay. And each time China does something strange, like issue some kind of proclamation about cryptocurrencies, issue some kind of new law, issue some kind of new anything really which deals with cryptocurrencies and especially Bitcoin and Ethereum, the value of Bitcoin and Ethereum either goes up or goes down, right? So if we could say that, I don't know, certain people have envisioned Bitcoin to be a tool for anarchism, right? They have envisioned Bitcoin to be the solution to the problem of evil banks. And the idea was to use Bitcoin, to use cryptocurrencies in a way which would basically fight the system. I mean, I know that in this audience there are quite a few people who would really like such a world or such an agenda, but in reality, we have replaced, in Bitcoin, we have replaced banks with unknown Chinese wealthy milliardaires or, unknown persons of huge economic impact. There are stories about certain mining operations, certain data centers being built in China. And near those data centers, entire new power plants, entire new power generators, which power only blockchain mining operations. Right? So, if you have an enormous amount of money and you have an enormous amount of political influence in China, you build a data center for mining Bitcoin and you build a power plant next to it to power it. Almost all power, electrical power in China, comes from coal, from burning coal. And that's another thing. Okay, so if you have Bitcoin, it's a public blockchain, so everyone can download it, everyone can use it, everyone can mine it, if you are a Chinaman. If you have a private blockchain, that means you have some kind of restrictions on these operations. So either only certain people can download it, only certain people can access the blockchain, or only certain people can mine it or create new blocks on it, or some other kind of restrictions. But compared to a public blockchain, it's not as free, it's not as public as a public blockchain. So, to demonstrate this, I will go through a blockchain I made from scratch, and I named it Daisy because I was sort of drunk that day and sort of got the idea of daisy chain, which may or may not be applicable to this one. And this is mostly a learning project, and I hope, obviously, I hope that I will actually use it somewhere. I hope that some rich Chinaman, comes and contacts me, but we'll see. And it's open source. It's on this URL here, and now I will go through it to show you how it's structured and what it does. So, this blockchain has blocks which are SQLite databases. SQLite is a small embedded database engine which uses ordinary files, a single file for each database. So you can basically create a random application, and you can use, through SQLite, a single file as your database. So you don't have to connect to Oracle, you don't have to connect to MySQL, you don't have to connect to, I don't know, MongoDB especially or something else. You have a single file which represents all your data, which holds all your data. This includes SQL indexes, table structures, really everything which is needed by database. So, blocks are SQLite databases. It's a private blockchain in the sense that only certain people can add data to this blockchain. Only certain people can create and mine new blocks. Right. So what does it mean? That means it's not really like a Bitcoin stuff. It's not really intended to be used as a cryptocurrency, although it can be, but it's intended to be used for data distribution. And the next criteria is the set of special nodes. Those nodes which can create new blocks is intended to be dynamic, to grow. And what are the consequences of this? Okay, so now you can have a blockchain and use SQL to insert and query data in this blockchain. You can have new blocks which contain arbitrary data. There are some, of course, there are some system tables involved which you do not touch, but otherwise you can create ordinary SQL tables, you can insert data to it, you can issue queries along the whole blockchain and get a result from it. And this is a pretty useful feature. You can basically store whatever you can store in SQLite, and this is quite a lot of data. Okay, the private part is implemented like this. So there's a set of public keys, there's a set of key pairs, let's say, which is allowed to create new blocks. So new blocks in DAISY are created in this way. Somebody creates an SQLite database. It fills it up with data. Okay? It passes it to a special utility which creates some special tables in this database, and then cryptographically signs this database with the private key of its creator. And then it sends it into the peer-to-peer network to be attached to the blockchain. Okay. This means that only certain people can create new blocks. Only certain people can grow the blockchain. But to be interesting, really, I made it that this set of keys, this set of signatories which can create new blocks, can grow in a way that existing nodes, existing signatories can vote on accepting new ones into their list. So if, I don't know, if there are 5 institutions or nodes or whatever which create new data, 5 companies which create new data, they can vote by using cryptographically signed transactions. They can vote to accept a new one into their list. So it's sort of a web of trust phase, sort of like PGP. Use cases for something like this. Well, the most important use case, the most interesting use case for me is basically in distributing sensor data. So imagine a large network of sensors which is organized around certain hubs. And this is a common organization. You have, for example, a hub which serves for, I don't know, hundreds of individual sensors. And all those sensors report data to this main hub. Okay, this hub can collect the data into blocks and then sign those blocks and add it to the blockchain. And in this way, you can, for example, get historical data of sensors through time, which are signed, which are distributed in a blockchain way. But this analogy, this metaphor obviously applies to other things. For example, imagine if legislature, if laws are distributed in this way. You have a blockchain, and every time a new law is signed into effect, it is signed and added to the blockchain of laws, for example. So I think it's an interesting thing to do. A couple of months ago, I was in a meeting, and another idea popped into my mind. You know those barcodes you see everywhere in shops, in products. You buy, for example, a bottle of beer or something, and you have this barcode attached to it, and this barcode gets scanned when you pay for it, right? So there's a global organization which hands out these barcodes. They are numbers which uniquely identify a product. And there's another piece of legislature which says that every food product must carry a list of ingredients, their nutritional facts. So this is the table of nutritional facts on every chocolate or beer or whatever else you have. So wouldn't it be great if you had a single application on your phone and you can scan this barcode of whatever, and you can get the list of nutritional facts on your phone directly from the network, right? And this is a use case which could be applied with multiple otherwise hostile or competitive companies. You can have, I don't know, Coca-Cola appending data to the blockchain about their products. you can have Pepsi appending data to the blockchain for their products. And this blockchain is publicly distributed, you know. But if you get a block which is created or signed by the Coca-Cola company or Pepsi company, you know it's valid. You know the data in it is valid. So this is kind of a useful thing. Ethereum sort of experiments, it's an experimental branch of Ethereum, which does sort of something like this. They have the proof of authority thing. And it also goes into the direction that only certain nodes can create new blocks. So this is something which will probably be very useful and talked about in the future. Okay, so this has been a lot of information, I think. I hope to present a few key points on all this. So, the first one is blockchains do not need to be about cryptocurrencies. The term blockchain is more like a database. You can store in it practically whatever. The second thing is that the experimental blockchain I've created uses SQLite databases, so you can insert SQL data, you can query the data in SQLite way. And that it's time to abandon, or not to abandon, to expand the idea of blockchains for use not only for currencies, not only for financial data, but maybe to, cooperation between companies or, business to government or government to business actually, or something like this. In the end, all of those things I mentioned can be Googled. I mean, please, search on it. If somebody tells you that blockchains can or cannot do something, all of this is public information. All of this is everywhere on the internet. You just need to Google it. Yeah. And if you want some other information on blockchains or, DAISY or something like this, feel free to contact me, obviously. I think we have 3 minutes left for questions, and thank you very much. Yeah. Okay. So SegWit. So SegWit is a technology which has been recently very publicly exposed or very publicly debated in the Bitcoin community. I mean, practically nobody else knows about it except Bitcoin enthusiasts. The idea is to increase the transaction rate of Bitcoin. So a few slides ago, I had this data that between 3 transactions per second and 7 transactions per second are at all possible in Bitcoin. So this is nothing. This is, this low transaction rate makes it unusable for any kind of transactions, not only microtransactions, but any kind of financial transactions in the real world. Okay, so SegWit is one of the technologies which was created mainly to expand this transaction rate. Okay, so SegWit in this frame, in this context, has increased the number of transactions from, 3 to 7 to about times 4. So 12 to 7 times 4, 28, right? So even with SegWit, you have increased the capacity of Bitcoin to a maximum of 28 transactions per second. This is nothing. This is still hugely inadequate for Bitcoin to become a global financial network or carrier. SegWit also has some other additions. It changes the way transactions are recorded in the blockchain. I think the other additions are mostly okay. So I don't see any security problems with it. But SegWit itself is not radical enough. I support SegWit because it's better than what we had before, but SegWit is not radical enough. It needed to be much more radical. So the Lightning idea, I think, should go on. It should be implemented as soon as possible. Okay, or something like it, but something which will increase the capacity of the Bitcoin network to actually be useful as a financial transaction mechanism globally. Okay. The other idea is, what will some states or what will some countries do with the idea of cryptocurrencies and blockchains? As I mentioned, every time China mentions Bitcoin or Ethereum or something, the value of Bitcoin goes up or down. You know, this is a completely different thing. But the idea of using blockchains for distribution of governmental data, so for distribution of certificates, driver's licenses, such type of information which need to be accessed by everyone, I think is actually a good idea. I think this is something which needs to be done. I've not heard of anyone actually implementing such things. So there are talks, there are articles which announce that this is happening, but I don't think anyone has actually started doing it. I mean, we don't know what China is doing, and we don't know what, I don't know, maybe Russia is doing, but nothing which is really publicized is available on this topic. And it's a good thing. I think it's a good idea to implement. Okay? Excuse me, can you speak louder? Okay, the question is how to secure the blockchain if you don't have the hash power of, the whole of China. Like this. Why do you need proof of work to have a secure blockchain? You can have the blocks signed, the algorithm which secures blocks does not need to be proof of work. It can be ordinary cryptographic signatures. So if you have a key which is held by your government or whatever else organization, you can verify that the new block in the blockchain is indeed added or created by your government. So proof of work is not necessary. This is one of the main ideas here. Proof of work is not necessary for cryptocurrencies and blockchains. Cryptocurrencies are not required, not necessary to have blockchains. Blockchains can be used for much, much wider purposes than today are, which are used today. Okay? Some other questions? So why does proof of work exist? Proof of work exists because parties do not trust each other. So the basic thing which is solved by having proof of work is to have parties which do not want to use key signing or signing the data by keys, and to use an algorithm which is so computationally hard that it is impractical to forge. So if you waste so much energy in creating a single block in Bitcoin, you would be crazy to waste as much energy to forge it. And if you want to forge a block which is, I don't know, 10 blocks removed from the current one, so 10 blocks in the past, you will need to forge this block, and 9 other blocks. You need to spend 10 times as much energy to forge this part of the blockchain, if you wanted to. So in this way, as much energy is wasted for creation of new blocks in Bitcoin. The upside of it, the reason for this is that so much harder is it to forge those blocks. Okay? Yes. Okay, for backing up, that's probably the least concern because everybody would have a copy. The problem of the size of the blockchain is general, so it's not something which is unique to any particular use case, either cryptocurrencies or governmental records or anything else. Currently, I think the Bitcoin's blockchain is about 100 gigabytes, something on the order of this, right? And this means if you want to have the entire blockchain on your computer, you need 100 gigabytes of space. In 10 years, you'll probably have, I don't know, a terabyte, whatever. There are a couple of proposed solutions to this. One such solution is creating checkpoints. So every 5 years, we say, okay, we're starting a new blockchain. And we are collecting all the end results. So all the end results, for example, all the address balances, all the coins belonging to certain addresses, we collect them, we create a new special block, and we create a new blockchain from this data on. Okay, so in a way we can reset the blockchain every 5 years or something like this. This is one solution. But in general, this is not something which is worked on. I mean, those are only ideas. Nobody is actually working on such a problem. I mean, and it gets worse, because if we increase the rate of transactions going on in the blockchain, we will also increase the size of the blockchain. If you have, for example, I don't know, I've calculated something like 1,000 transactions per second, you would need, I think it was on the order of 4 terabytes a day. If you put them all in the single blockchain. If you put 1,000 transactions per second in a blockchain, I need to verify the data, I've calculated it a long time ago, you would need, 4 terabytes daily. I cannot give you an answer because nobody has actually implemented any answer to this. I think that checkpointing or, starting new blockchains every couple of years would be the best solution. So we don't have any time. So if there are, important and very interesting questions, then one. Otherwise, let's speak outside. Okay. In the context of DAISY. I'm not sure I understand the question. So, right? Okay. Okay. Yes. So the question is, how do we know who created a block in a blockchain? So the general answer in currently implemented blockchain is we don't. So the blockchains of Bitcoin, Ethereum, and such popular cryptocurrencies do not directly contain any authorship information. So this is not present in the structure, so no. In the case of, for example, DAISY or something like this, in particular DAISY, it implements a list of keys which are allowed to create new blocks. So this list of keys is also not directly related to ownership. It doesn't contain ownership data. But if this is modified to use, for example, certificate authority certificates, which, for example, guarantee that a key belongs to a certain organization, then we would solve your problem of, pretty much guaranteeing that a certain block is signed or created by a certain party. Okay, so I hope this is an interesting topic. I mean, obviously it is an interesting topic, and I hope that you've learned from me. And if you have any more questions, if you have any more ideas you wish to share, let's talk aside. Thank you.